Hey everyone, welcome back to another video of mine, where today we're going to be solving Leetcode problem 78 titled Subsets. So we're given an integer array nums of unique elements, and we simply need to return all possible subsets of that array nums, right? And this is also called, alternatively, the power set, right? So the solution set must not contain duplicate subsets, and we can return that solution set in any order we'd like. Right, so in example 1, we have a nums input array of 1, 2, and 3. And so our output would be the nested lists or solutions of all the subsets possibly made from that input array nums, which in this case is going to be starting off with an empty subset, right, or an empty array, and then 1, 2, 1, 2, 3, 1, 3, 2, 3, and 1, 2, 3, basically all the elements. So two major key things to note here is that an empty array or an empty set is always going to be the subset of any possible input, right? It's even going to be the subset of an empty set, right? Which brings me to the next point, right? An array that matches the input is also always going to be another subset of the input, right? For example, if my input was 2, 3, 4, sorry, there should be a comma here, 2, 3, 4 is going to be a subset of itself. Every single array is actually considered a subset of itself, which is another important thing to note, right? And so we're going to be solving this problem using the backtracking algorithm, because whenever we're trying to generate a large or at least even nested lists of solutions based on processing and parsing the input, like permutations, combinations, subsets, or so on and so forth, the best algorithm to use in that case is backtrack, and to go back and explore every different path and every single different subset or subarray made and formed from one given input, right? So what I'll do is I'll actually initialize a result variable, right? And what this result variable is going to do is going to be initialized to an empty array, and at the end of my backtracking algorithm or function, this result variable is essentially going to store all the different subsets once we're done dynamically appending to it, and so we can eventually simply just return result, which is eventually going to have all the different subsets embedded within it. Alright, of course, if we were to submit this now, we'd simply get an empty array because we haven't actually defined or started our backtracking code yet. Right, so now that we have a result array initialized, let's actually start defining the backtracking part of this code. So we'll define a backtracking function, right? And let's just take in two parameters here. In fact, I forgot a k here. Sorry about that. Okay, and let's just take two parameters here, right? The first parameter that we're going to take is the starting index, right? And the next parameter we're going to take is the current subset, or basically the current subset that we're building up based on this specific iteration of our processing through the input. Right, so now that we've defined our two parameters, let's immediately just append to our result variable a copy of the current subset. Right, and basically what this is saying is, once we're done with the code, and once we continuously, while we recursively call our backtracking function, we want to append to our result array the copy of the current subset that we're looking at right now. It should be just u, right? And you'll see how that forms a little bit in the future, right? So we have a result, and we're basically appending the current subset that we're looking at in this specific iteration to that array. And now we'll actually loop through the indices of our backtracking, of our input nums, and we'll add nums at I based on our specific iteration, and keep incrementing our iterator by 1 as we recursively call our backtracking function, while we append the current subset that we're building to our result variable to account for all unique and different length subsets. Right, so we'll say for I in the range of length of numbers, and we'll actually start from the starting index, right? So for I in the range from the start to the length of the numbers, we simply want to append nums at I to our current iteration. So we'll say current subset dot append nums at I. So basically we're adding the ith indice or element at that ith index or position in our input array nums to our current subset, right? And this is where the recursive calling part of this function really comes into play, right? We keep calling our backtracking function, we keep calling our backtracking function with our starting index, of course, to be I, basically the index that we're currently looking at and appending to our current subset, and of course our current subset itself, right? Because we're going to be dynamically adding each ith indice or value to it as we build it up for one specific iteration from our for loop, right? But there is an issue here. We can recursively call this backtracking function to continuously keep appending nums at I to our current subset, but the only issue is we're only then going to get one possible subset, and that's going to be the nums array itself, because we're going to be starting from the 0th indice and looping through the length of the nums, right? That's completely fine, but the only issue is we never actually increment our iterator, or our ith indice, right? We just stay at 0, basically what we initialize it to be. And so if we don't never increment it, we're never actually going to get we're never actually going to get subsets that are a different length than our nums input array itself. And so if we want to decrease and modify the length of our current subset, what we want to do is we actually want to increment our indice or iterator by 1 to explore all the different paths and move on to different lengths of subsets within our input array nums to actually add to a result. Right, so we'll call backtrack at I plus 1 to move on to the next indice, and then we'll pass in current subset as our current subset. And we don't actually need to add anything in our current subset for our parameter within the backtracking recursive call of this function, because it's already going to be added to with nums of I on line 7 as we continuously call that function itself, right? So another thing that we really need to keep track is that, sure, we may be calling and recursively going back to this function, but again, we're still only going to get one possible subset if we don't actually explore all the different paths, right? And to explore all the unique paths and all the different ways we can rearrange and group the indices differently in our different subsets, we actually need a pop from our current subset to move on to the next indice to choose whether to include it or not in our current subset. So also current subset dot pop. And just to visualize this a bit easier, it's kind of similar to the permutations problem. If we were looking at a subset currently that was, let's just say 1, 2, and 3, this may be a valid subset within our array, but if we never pop or remove and undo an element from our current subset, we're just going to keep adding nums at I until we actually hit the length of nums and simply add that to our final array. But we're never actually going to explore any different paths with our different numbers and different rearrangements. So let's just go back to our original position where we were at 1, 2, and 3. Let's say in this current subset, I don't want to include 3 in our current subset for this iteration. Let's say I want to just directly jump to 4 and not include 3. I'd pop the most recent element that I added from my current subset like this, and I'd go to the I plus 1th indice, which in this case is going to be 3 plus 1, 4. The indice after 3, which in this case in our input array nums is going to be the value 4, which does account as a unique subset because it has different occurrences of different elements in this subset from 1, 2, and 3. And that's how the popping method typically works, similar to how we did it in the permutations problem as well. Right? So once we actually current subset.pop, this will enable us to actually explore all the different paths which we can dynamically append our final array with of our current subset. And believe it or not, that's actually the entire code for the backtracking part of this. And what we honestly have to do after that is simply call the backtracking function, right? And for our starting index, of course, we'll start from the beginning of the array, so we'll have to pass in an index of 0 or the 0th value or indice in our input array nums, right? And for our current subset, since we haven't actually scanned through the array yet and it's going to start off empty, we'll pass in an empty array, or basically something without elements, right? And after we've done this and called the backtracking function and finished for it to be executing, we'll eventually have stored all the unique subsets that we can form from our input array nums and have added it already to our result from line 5. And so once we can do that, we can simply return result because it will have been already storing all of the different possible subsets that we could have within our input array nums. And if I were to submit this, unless I made any syntax issues, this should be completely fine. And yes, as you can see, it's just about as efficient as you can get, beating 73% of users runtime-wise, and memory complexity-wise, it beats 70% of users, right? So if we were to analyze the complexity for this problem, in this case, the runtime complexity for my solution is going to be O of 2 to the power of n, because that is the definition of all the different possible subsets of an input array nums, or any input array. Right? We can either choose to include or not include the current element that we're looking at, hence what the pop method does. And so it's going to be 2 to the power of the length of the input array to see, because we have 2 choices for every element to include it or not within our specific iteration or the subset. right? And memory-wise, this is going to be oben, because we're really only using one extra data structure, which is going to be the result variable that we add all the different subsets to based on the length of our input array nums. So if you guys learned something new and enjoyed the solution, please make sure to subscribe and like to my channel. It really does mean a lot, and I hope you guys learned something new. Bye-bye.